All right, what's everybody? What's up, everybody? Um, Hope you're all doing good through this Corona scare. I do believe we're going to get through this. So, in accordance with that, I want to make a video and take the time out on this Saturday in March 26th or 7th. I can't even remember. Anyways, bottom line is I want to make a quick video about the trade of machinist. Certified machinist is somebody who makes precision parts dealing with aluminum, steel, and other metals, even into plastics. Typically, most machinists will work with metal, but again, machinists do work with plastics and polymers and synthetic materials other than natural metals like aluminum, alloys, and steel, and bronze, copper, you name it, there's any kind of metal. So I got involved in the trade about 7 months ago when I signed up to go to a technical vocational college in Santa Fe Springs. Some of you have heard of it, NTMA. And that started my journey into becoming a certified machinist. So for the past 7 months, I've been training, taking exams, getting hands-on instruction, and I really like it. So I just want to pass on a little bit of what I learned and just talk about the trade itself, and maybe get somebody out there interested in becoming a certified machinist. So just a quick overview of some of the stuff that you see here. This hammer, you see it's knurled. We made that in the school on a lathe. A lathe is a machine that spins parts in a circular motion, and you make cylindrical type shapes from the lathe. So in this particular case, let me set this down just so you guys can get an idea of what we did. When we made this hammer, this screws off. We had to taper the shaft. So the shaft was basically just 6061 aluminum, which is your standard aluminum alloy. And it looked like this when we first started. Not this length, but this is basically how it looked. It was just a piece of aluminum. And as you see, the circumference of this diameter is the same, because this is a scrap piece that I kept because it duplicates or replicates what we started with. And I wanted to show that as a contrast. So from this piece, it's going to end up like this. You knurl it, you create a radius in the edge here. You can see that tip is where the livestock was pushing against it. Livestock is like a needle that presses against the back here as it spins. We had to do a threading job. That was a lot of fun. We had to learn how to thread on the lathe. And as you see, there's more radiuses here. There's all kinds of stuff going on here that we had to learn. This may not look like much, but there's a lot of instruction that went into making this. Then you see the taper. As it tapers off, you had to set the machine to do that, just like you had to set the machine to do this knurling job. And then, of course, drill all that out and thread and tap it. So we had to drill and tap it and put threads on it so that they all fit, and they had to fit. You could make this too big and mess it up. You could scrap parts. Scrapping parts is not good. That means you made a mistake and you have to start all over, and you don't want to do that. But this came out good. It's just a basic little machinist hammer. We had to make this nylon, which is also synthetic. This screws off, as you see. And when you look inside here, you'll see that we had to also screw a hole in there. So we had to thread, and then you get this fastener to attach, and it has to fit. So you have to do it properly. But that's the fun of it. Screw all that in. Then you have to taper this off, drill a hole there, and then attach it by screwing it in. And that's one of the projects we had to do in the school. It's a lot of fun. Another thing I'll talk about is parallels, which is basically these right here. We had to start off with just same thing. It was a tubular piece of steel, cold rolled steel, 1018, which we cut in half. Then you precision grind, drill holes, and you slot it out right here like you see there. It's been slotted out and drilled out. And then we had to chamfer it, which is basically break all the sharp edges. So it's chamfered. Then we send these off to get heat treated, which makes this a harder, more hardened, it's a hardening process from the Rockwell hardening scale, which I don't know what this would measure on the Rockwell hardening scale, but it's harder. It's been heat treated, so it's harder. When it came back from heat treating, we took it to the grinding room at the school, and we precision ground these so that they're equal, as you can see. So they marry up. If you look down there, everything matches. So that when you use these in the jaws of a vise and you put your parts between them, this is a precision measuring reference point so that your part will be within tolerance because it's equal sides. So that's what these are for. It's one of the projects you'll do if you take the class. We also made this. This is from 1018 cold rolled steel. 1018 just talks about which is the most common steel out there, that the amount of carbon, which I believe it's 18 parts. So 1018. So that's why it's called 1018 steel. So this has also been precision ground that we did that ourselves after it was heat treated. Not this, but this. Same thing. It was cut in half. We had to cut it ourselves after we measured them, and we precision ground them on the sides all the way around as a measuring point. So then we later on, as you advance in the school, you take some more metal and you grind, or you machine this in the CNC vertical mill, and there's a program you write for that. This we did conventionally by hand, and this we wrote a program and the machine did this. So we programmed it, cut these two pieces, had to drill it out, and then they have to fit with a really snug fit. It has to be tight. So there's very little wiggle room. So therefore, it's a measuring point. So you can put a piece of metal or whatever in there. It's really a tight fit. And then you put like a screw, a fastener here, through there, through that hole. That's a threaded hole to press against that part, that stock, and hold it in place as you do your milling or machining on the exposed part. And this should be a good reference point for measuring, as you see that V cut, to give it that perpendicularity, or just it's going to be precision cut, because this is precision measuring as a reference. Okay, so now we're going to look at these two pieces of aluminum and steel. They're about the same diameter. This is lighter, this is heavier. This is 1018 cold rolled steel, and this is just 6061 aluminum. Very typically what you're going to use in a trade school like what I just went to. It was a privilege to be able to use this material because it's expensive, and we got to, cut stuff and make mistakes. Another one, let me show you real quick what we did here. We did that. So this is one of the projects where you get to engrave your name. I put my military rank there. And the CNC, Haas CNC, cut all these holes, drilled all these holes, cut all these little chamfers and holes and these little designs and things like that off of a piece of 6061 aluminum. And it's a business card holder, obviously. And came out really well. I was very happy with it. Everybody pretty much did this project. It's a lot of fun to do. Again, it's just a business card holder, and I put my DJ business cards in there. If you guys need a DJ, I'm not just a machinist. Don't hesitate. Weddings and parties. Okay, back to machinist stuff. So you have your parallels here, which are precision ground, cold rolled steel. You have your V blocks, also precision ground, cold rolled steel, and your V block clamps, which are not precision ground, but they are cold rolled steel. This is the 6061 aluminum hammer that we made, just a machinist hammer. You always want to wear safety glasses. These are particularly tinted, so I wouldn't wear those in the shop, but they are safety glasses. And these are your measuring tools, calipers, and OD mics. In this particular case, this is a Starrett micrometer OD mic. That's a Mitutoyo digital. This is not a digital, this one. It's a standard, but it has a vernier scale on it. Let's see if it focuses. You have a vernier there, a vernier scale. This one also has a vernier scale on it, and it's digital. You can see the comparison of the two. 0 to 1 OD mics. So they measure outside diameters of things. And you can see the digital readout right there. 0 to 1. Decimal places, 4 decimal places. That's what we typically work with. And then last but not least, my dial calipers, which these have 200 thousandths of travel, 200,000, so 100,000. You basically go like this. So you can see here, if I can focus, to an inch, 100,000, 200,000, 300,000, 400,000. Focus. 5, 6, 7, 800,000, 900,000, and then an inch. And it just keeps going. Another 6, 700, 800,000, 900, then 2 inches. 2 inches, 100,000, 2 inches, 200,000, 2 inches, 300, and it keeps going like that. So this is to measure the outside diameter of parts, like so. So that's basically how you use these tools. Thanks for watching. Out.